2:13 a.m. on December 2, 2025, one of the coldest regions in western Russia was silent. Mordovia was locked under a deep freeze, temperatures well below zero, snow covering the ground and absorbing sound. At that hour, even industrial zones were dormant. Then, without warning, the silence was shattered by the sharp mechanical crack of 30mm autocannon fire. 11 Ukrainian drones were already inside Russian airspace, descending rapidly, executing a direct suicide approach into the engagement envelope of a Russian Pantsir S-2 air defense system. The cannons opened fire not as a precaution, but as a last-ditch reaction. 48 hours earlier, Vladimir Putin had formally rejected a Ukrainian-backed peace proposal. This was Kiev's response, delivered at approximately 118 miles per hour. The objective was not symbolic, it was singular and absolute. If the drones failed, Russia would retain its monopoly on fiber-optic drone warfare. If they succeeded, the Russian military would lose the only domestic facility capable of producing fiber-optic control systems at scale. The margin for error was zero. Time to impact was measured in seconds. 7 minutes earlier. Far above the frozen plains of Mordovia, a different phase of the operation was already underway. At approximately 800 feet above ground level, a shadow with a total mass of 155 pounds was moving silently across the terrain. This was the FP-1 Mother drone, the central delivery platform for the entire strike package. The FP-1 was cruising at 115 miles per hour. Its electric propulsion system was running at precisely 17% output. That number was not arbitrary. At 18%, the thermal signature of the motors crossed a detection threshold that Russian infrared sensors could reliably track. 17% was the maximum output that allowed the drone to remain indistinguishable from background thermal noise. The aircraft was flying just 130 feet above ground level, skimming the frozen landscape and threading a narrow digital corridor. 400 meters away, inside a hardened bunker in Kiev, Colonel Alexei monitored the mission feed. His tactical display was dominated by a red overlay that represented the primary threat to the operation, the engagement envelope of the Nebo-M radar system. The Nebo-M is one of Russia's most capable long-range air surveillance radars, designed to track up to 300 targets simultaneously at distances of up to 400 kilometers. It is a cornerstone of Russian Aerospace Force's early warning capability. Inside that massive detection ring sat a smaller, far deadlier zone, the 12-kilometer engagement envelope of the Pantsir S-2 short-range air defense system. At the exact center of both rings sat the target. To an untrained observer, it was simply an industrial factory complex. To Ukrainian planners, it was the single point of failure in Russia's future drone warfare strategy. This facility produced fiber-optic guidance systems that allowed Russian drones to remain immune to electronic jamming. Destroying the plant would not merely halt production, it would erase the technical foundation that enabled an entire class of unmanned systems. For the previous 400 miles, the mission had unfolded as a controlled demonstration of stealth engineering and atmospheric exploitation. The drone swarm was riding a low-level jet stream moving at approximately 60 miles per hour. This tailwind effectively masked their true ground speed, allowing Russian radar systems to misclassify them as slow-moving meteorological clutter. To radar operators in Bryansk, the composite airframes of the drones appeared no different than drifting snowfall. The returns matched the velocity, density, and dispersion patterns of weather artifacts. The classification algorithms labeled them accordingly. "They still think it's weather," Colonel Alexei remarked quietly from Kiev. But atmospheric physics does not remain static. The ambient temperature outside was approximately -12 degrees Celsius, 10 degrees Fahrenheit. While the extreme cold was ideal for cooling the drone's motors and electronics during cruise, it introduced a critical vulnerability during the attack phase. As the drones descended and prepared for their terminal run, they would need to increase throttle. Lithium battery packs running hot against a frozen background do not resemble clouds on infrared sensors, they resemble flares. Inside the Nebo-M operations room in Bryansk, the night shift radar operator was on his third cup of coffee. Fatigue was already setting in. He had no indication that exactly 7 miles away, his drifting snowstorm was about to bank left, increase speed to 125 miles per hour, and attempt to penetrate a billion-dollar air defense network. At 6 minutes to impact, the environmental conditions began to shift. The tailwind weakened. The masking effect began to degrade. To maintain their timeline, the Ukrainian mother drones increased throttle. The moment their ground speed exceeded the wind vector by 5 knots, the Nebo-M's Doppler filters stripped away the weather classification. In Bryansk, the display changed instantly. The storm turned crimson. An anomaly alert triggered, bearing 211 degrees, speed increasing. This was no longer weather. The operator initiated a threat escalation. What followed was one of the deadliest races in modern warfare, unmanned systems traveling at roughly 100 knots versus command signals traveling through copper wires in Russia's legacy telephone networks. The order Condition 1 was transmitted to the factory's air defense detachment. The drone swarm covered the next 5.3 miles in 2 minutes and 10 seconds. Every second brought them closer to the Pantsir's kill zone. At 7 miles from the target, the Russian air defense network fully activated, but it was already too late to stop the delivery phase. 5 FP-1 mother drones pitched upward to 2,000 feet. Their belly hatches opened simultaneously. Gravity took over. 20 Wild Hornets dropped into the freezing slipstream. These were not sophisticated platforms. They were designed to be cheap, aggressive, and expendable. They existed to absorb fire, confuse sensors, and die if necessary. But the 6th FP-1 was different. Trailing slightly behind, it released 4 Calibri drones. These were not suicide platforms. They carried laser communication terminals, the only systems capable of maintaining control once Russian electronic warfare assets were activated. With their payloads released, the FP-1 drones shed 130 pounds each, banked sharply, and exited the battlefield. Their mission was complete. The swarm they left behind was entering the most lethal phase of the operation. The 20 Wild Hornets dispersed instantly, spreading outward like a shotgun blast. Their onboard AI initiated the stop-and-go protocol. Below them, the Pantsir S-2 radar systems began screaming with conflicting data. Pantsir's engagement logic relies heavily on Doppler prediction. The system calculates where a target will be several seconds into the future based on its current velocity vector. The Ukrainian software exploited that dependency. The Wild Hornets accelerated to 90 miles per hour, then abruptly halted. They hovered, then they sprinted laterally, then they hovered again. Each time a drone hovered, its radial velocity dropped to 0. To Doppler radar, it effectively vanished into ground clutter. Inside the Pantsir command vehicle, tracking symbols jittered and skipped. The system struggled to maintain lock. The computer flagged the problem. Trajectory prediction failed. Radar lock unstable. The Russian gunner fought the controls, attempting to reacquire a firing solution. "I can't get a tone," he shouted. The commander made a decisive call. Radar was no longer effective. "Switch to thermal," he ordered. The gunner selected guns. The Pantsir's twin 2A38M 30mm autocannons spun up. These weapons do not fire in measured bursts. They deliver continuous streams of high-explosive tungsten rounds at a combined rate of approximately 5,000 rounds per minute, roughly 83 rounds per second. The first volley was brief. 3 Wild Hornets caught mid-hover were instantly destroyed. Each 30mm shell carried approximately 48 grams of hexagen explosive. Impact did not merely damage the drones, it disintegrated them. Carbon fiber and lithium became dust and flame. Target destroyed. The gunner ignored automated tracking cues and switched to manual control. He hunted the glowing thermal signatures directly, sweeping the turret smoothly. A fourth drone attempted to dive. A single round clipped its rotor arm. Traveling at approximately 3,200 feet per second, the projectile sheared the limb completely. The drone spun uncontrollably and impacted the frozen ground, detonating in a fireball. 2 more drones attempted a pincer approach. The gunner calmly walked the tracers across their path. Proximity-fused shells detonated near them, shredding the airframes with tungsten fragments. In 18 seconds, 9 Wild Hornets were eliminated, but the engagement had shifted. The gunner reoriented toward a cluster of 4 slower-moving targets at the rear of the formation. These were the Colibri drones, the carriers of the laser communication links. The crosshair settled, the barrels spun. Ukraine had 38 seconds remaining. The first tracers were already leaving the muzzle when the Russian gunner made his critical mistake. He had become fixated on the easiest targets. He assumed the remaining Wild Hornets were retreating. They were not. They were repositioning. Within the swarm's neural network, a logic gate flipped from evasion to execution. The AI recognized that it could not win a sustained gunfight. It chose a close-quarters solution. The surviving 11 Wild Hornets synchronized. Then they dove. They did not target the armored hull of the Panzer. They aimed for its vulnerability. The unarmored optical module mounted atop the turret, the thermal sensor guiding the guns. The commander shouted a warning, but the turret's mass and traverse limits worked against it. It could not elevate fast enough. 1 drone was destroyed by direct fire. Another clipped the radar dish and spun away, but 3 reached their target. Shaped charges detonated directly against the 10ES-1 sensor suite. There was no fireball, only a precise concussive shock that shattered lenses, severed circuitry, and tore the thermal camera from its mount. Inside the Panzer, screens went black. "I'm blind," the gunner shouted. "Sensors are down." The turret continued to rotate, firing blindly into the night sky. Without targeting data, the system was reduced to noise. The guns fell silent. 5 Wild Hornets had sacrificed themselves to achieve that silence. 6 survived. Hidden among tree lines and rooftops, they waited. Above the smoke, the 4 Colibri drones stabilized and deployed compact optical pods. They resembled camera lenses, but their function was different. They emitted light. A beam of invisible 1550 nanometer laser energy connected the drones to a relay pod descending under a parachute miles away. This was free space optical communication. Unlike radio waves, which spread broadly and are vulnerable to jamming, laser communication is tightly focused. It cannot be intercepted unless physically blocked. Nearby, a KUS-4 jamming system flooded the spectrum with electronic noise. It was irrelevant. On Colonel Alexei's display in Kyiv, the connection lost warning flickered, then turned green. Latency, 4 milliseconds. The video feed appeared instantly. 4K resolution, no distortion. Control was fully restored. But the Colibri drones were not just transmitters, they were routers. They rebroadcast encrypted short-range signals to the 6 surviving Wild Hornets below. The swarm was reconstituted. 10 drones, 10 warheads, 10 live feeds. The target complex covered 4 acres. Intelligence had already identified the critical nodes, not administrative buildings, not warehouses, but the silica draw towers, 3 massive 3-story ovens operating at approximately 3,600 degrees Fahrenheit. These systems pulled molten glass into fiber strands thinner than human hair. They were delicate, expensive, and custom-built. Assignments were issued. Team Alpha, 3 Wild Hornets on the power substation, Calibri team and remaining Hornets, precision strikes on the draw towers. The logic was straightforward. The draw towers required constant cooling. A power loss would cause molten glass to solidify inside the machinery, destroying it permanently. Adding high explosives would ensure catastrophic failure. At 43 seconds to impact, the swarm aligned. The Panzer crew listened helplessly as engine noise grew louder. The commander exited the vehicle, seized a shoulder-fired Igla manpads, and fired it skyward without a lock. The missile missed its primary targets, but its blast wave disabled one Wild Hornet, which crashed into a parking lot barrier and detonated harmlessly. 9 drones remained. Team Alpha struck first. 3 Wild Hornets impacted the 110 kilovolt substation. Transformers ruptured violently, spraying burning oil and ceramic fragments. A massive electrical arc flashed blue across the facility. Then the power died. Cooling pumps shut down instantly. Inside the plant, alarms sounded on battery power. Temperatures in the draw towers began to spike uncontrollably. The final phase commenced. 2 Wild Hornets, configured as breachers, accelerated to 120 miles per hour and impacted the reinforced steel roof above draw towers 1 and 2. Their shaped charges punched clean, molten holes through the decking. The Calibri drones followed. Inside the production hall, illuminated only by the red glow of failing ovens, 4 thermobaric warheads detonated simultaneously. A 4,000-degree Fahrenheit fireball consumed available oxygen. Hydrogen tanks ruptured. The roof was torn away. Machinery liquefied. At 2:20 a.m., silence returned to Mordovia. Ukraine had spent approximately $400,000 on the operation. The destroyed facility was valued at roughly $1.2 billion. The silica draw towers were confirmed destroyed. Replacement timelines were estimated to 14 to 18 months. Russia's fiber optic drone program was effectively halted until at least 2027.